We're going to go ahead and continue on with our binomial experiment. So, be aware we're going to start to have inequalities as well as something that's equal to. So, for example, maybe we're looking at the probability of having 4 or less, people, I think we're just looking at who had O negative blood or something. So, here's your calculator tips. We are going to hit second, vars, and then distribution. If you go down to A, we get binomial PDF. PDF represents precise, so it's going to represent when you have the probability that x equals a specific number, so a precise number. CDF stands for cumulative, so it will do everything up into that. So this is going to be all your inequalities, so probability that x is greater than some number, probability that x is less than some number, probability that x is greater than or equal to, or even probability that x is less than or equal to. Okay, so I put down here the difference between PDF is probability. I think it actually does stand for precise as well. Precise density function versus cumulative. Okay, so be aware here. Usually when we look, we are going to have some type of cutoff. So let's say our cutoff is like right here is our question mark. If we have less than or equal to, we're saying, hey, what's the probability of getting any of these things over here on the left? With that in mind, then you just do the binom CDF on your calculator. However, with that in mind, if I use that same cutoff, but then say, hey, we actually want greater than or equal to that number, we're going to want the right side. The issue is our calculator will always give with CDF the left side of it, so this probability. So this is going to be our binom CDF on the calculator. So therefore, if I want to find the right side, I'm going to have to now do 1 minus the binom CDF of that left side. So just be aware that will come into play in a moment. Okay, we're going to have to skip this next page because once again we didn't do the nonsense test, but we'll do these 2 examples on the last page. So, according to an airline, flights on a certain route are on time 75% of the time. Suppose there are 10 flights randomly selected and the number of on-time flights are recorded. First, we want to talk about, is this a binomial experiment? So remember, we're going to abbreviate it with bins. So B represents binary, right? There's a success or failure. So it's either on time or not, right? Nothing between. I is the fact that they're independent, right? So if our flight's independent, one doesn't influence the other. For the most part, I'd say yes. And then N is a number, a set number of trials. So here we have 10 flights. And then S is that success rate. And we've got 75% of time on, maybe I'll say on time. So yes, it is a binomial experiment because it meets the conditions, right? So, find and interpret the probability that exactly 6 flights are on time. So we're doing the probability that x equals 6. Since we're doing the fact that it is equal to, we've got our binom PDF. As you look at your calculator, so if you hit second vars, it asks you for 3 things. So we go down to A, which is binom PDF, and it asks you at first, it says, hey, what are the number of trials? So in this case, we've got 10 trials. Then it says, hey, what is your P, meaning the probability of success? 75%, we're going to do that as a decimal, so 0.75. And last but not least, it says, okay, well, how many do we want? In this case, we want exactly 6. So we enter that, we hit paste and enter again, and it tells us that probability is 0.146 if I round it. All right, so with that in mind, the probability, as we're interpreting it, it says the probability that the number of flights on time is exactly 6 is that 1.146, or about 14%. So we're saying like, hey, if we had 100 trials, maybe this is a better way, so that's one interpretation, or we could say, hey, if we had 100 trials, right, we would expect, if I round that up to multiply by 100, I get a 14.6, so we expect about 15 trials to result in 6 on-time flights. Okay, so this next one's a little bit different. The reason I actually have my notes over here is because in general, we're kind of thinking about, I'm going to just draw a bell curve rather than the individual brackets, but that's what we're thinking about. In this case, rather than just having exactly 6 and looking for like that one thing, we're saying, hey, 6, let's call this my cutoff of 6. We're saying 6 or fewer than 6 here. So we're saying anything to the left of 6. Okay, be aware here. Oh, I just deleted that somehow. Sorry about that, guys. So I got my 6, and we're looking for anything to the left of it. So here we're saying the probability that x is less than 6. It will include our binomial. In this case, we're now going to start doing CDF, or to be cumulative for all those probabilities. It will include this number as well. So if I want the probability that something is simply less than 6, I actually have to do the probability that that's going to be equal to the probability that x is less than or equal to 5. Another way to think about this too is these are going to be discrete things. So what's a number less than 6? The next number less than 6, if it's discrete, is 5. So now I do my binomial CDF, and this time it asks for really similar inputs, or basically actually the same inputs. It gives us our trials, which is 10, the probability, which is 0.75, and then we've got 5 as our x value. Hit enter, enter, and then we get 0.078 as our response. I kind of ran out of room to interpret here, but basically we're saying, hey, if you had 100 trials, right, we would expect about 8 of them to result in fewer than 6 flights on time. Okay, this next one, when we say the probability that at least 6 flights are on time, probability that x is greater than or equal to 6. So I'm going to draw. It's not really a continuous curve. They're actually like individual bars, but we can get the idea from this. If we're saying, hey, I want anything that's greater than or equal to 6, right? In this case, you want to include 6 in your answer. So if I did 6 and below, the problem is it'd also take that out, but I want that as part of my answer. So rather than doing that, we would go ahead and to find this whole side on the left here, maybe I'll draw with a highlighter. This is going to be the fact that x is less than or equal to 5, right? So it's not including 6, so we got less than or equal to 5. So as we look over here, I can think about this being 1 minus that probability that x is less than or equal to 5. So if I do 1 minus that 0.078, we end up with 0.922. Okay. This next one's a little bit trickier. We want the probability that we have between 4 and 6 flights. So, probability that x is between, I'll do 4 and then 6 flights. Don't worry as much about writing that notation of the probability with that, but rather how you find it for the record. So if we think about this one, this time we want between 4 and 6. And I'd say there's 2 ways you could think about this. We could think about this as the probability of 4 plus the probability of 5 plus the probability of 6. Or I could say, hey, if I think over here on the right, I could take the probability of 6 or less, and then if I took the probability of 4 or less, I would be left with anything here between. So either way you want to think about it. Or we could say the probability that x is less than or equal to 6 minus the probability that x is less than or equal to 4. If we do this first one, we're doing exactly that number, right? So this will be binom PDF, right, of those different ones, whereas this would be the binom CDF of these. I'm going to show you the binom CDF, but we should get, if you did it the other way, the same answer. On the calculator, we're going to hit second vars and go down all the way to A. Actually, sorry, we're going to B this time because we're doing CDF. And we have 10 trials. Our p-value is 0.75. And this time, I'm going to first look at with 6. That would be when the x is less than or equal to 6. We hit enter and we get a probability of 22% or 0.22. I'll teach you a little trick. If you go up and then hit enter in the bottom right, you can actually edit that. I'm going to just change it to be 4. The probability to have 4 or less, you know what, I messed up there. If I want to include 4, I've actually got to do 3 or less, right? Because it's going to include that number. So to have 4 or less, that's a 0.003. So now, if I take the probability of having 6, and I subtract the probability of having 3 or less, I end up with a 0.221% chance. Okay, so here, let me change this. Remember what I said. This is actually going to be 3, right? Because we got to include it. So as I subtract those two, we end up with 0.221. Okay. We got just one more example to take a look at. So it says, according to a study done, the probability of a randomly selected individual will not cover his or her own mouth when sneezing is 0.267. And you wonder why we have coronavirus. I'm just kidding. Okay, suppose you, I should say, sit on a bench in a mall and observe people's habits as they sneeze. What's the probability that among 10 randomly observed individuals, so that's like your number of trials, exactly 4 do not cover their mouth? So remember, with the probability that x equals 4, we've got our binom, in this case, PDF for being precise. So our set number of trials is 10 again. Our probability, in this case it says they do not cover their mouth. So be a little careful. Actually it matches up here. Do not cover their mouth is at 0.267 for the probability. And then we're going to put in 4. When we type that in our calculator, we get 0.1655. Sorry, you may want to pause and just kind of check that you can get that in your calculator as well. Let's go to the next one. The probability that among 10 randomly selected individuals, fewer than 2 do not cover their mouth. So probability that x is less than 3. Be careful here. We are doing binom CDF, but remember, since these things are discrete, saying something is less than 3 really means that it's less than or equal to 2. And the CDF will always include that value at the end. So we're going to do the binom CDF of 10 and then 0.267. And then this time we've got 2. Take a moment, maybe pause the video, type that in your calculator, you get 0.4752. Last but not least, would you be surprised if after observing 10 individuals, fewer than half covered their mouth when sneezing? So in this case, we're saying the probability that x is less than 5. That's at least the way I think about it when I say fewer than half. So remember, that's the same thing, the probability that x is less than or equal to 4. So in this case, we're doing the binom PDF or CDF. Cumulative, because it is that inequality, we want everything up to 4, equal to. We've got 10 trials again, but this time notice how it says they cover their mouth. So if they do not cover their mouth, it's a 0.267. If I do 1 minus that amount, I end up with 0.733, and that's the probability that they do cover their mouth, which we're looking for here. And then 4. So when I put that in, I get 0.027.